funny things have happened since I started. I basically started this because I didn't feel I did well at a coding challenge in an interview, and lots of interviews I've had have had coding challenges. But since then, I've actually gotten a freelance gig, and it's funny when a client comes to you to build a website, or in this case, a mobile app. They don't give you a coding challenge first. But it's still a very useful skill. So, and I started this, so I'm going to finish it. And tonight's the last night, so let's do it. Okay, subtract the sum. Now, 61% of users were positive about this one, so I wonder what's not very nice about it. Well, we're about to find out. Subtract the sum. Uh-oh, this can be more difficult than regular 8 Q-katas. Okay, well, let's be prepared for the worst then. Complete the function, which get an input number. I'm already not impressed. Complete the function which gets an input number n, such that n is greater than or equal to 10 and n is less than 10,000. Okay. Then sum all the digits of m. Okay, sum. Okay. All the digits of n. Oh, I see. Not all the number. Okay, all the digits. Gotcha. Subtract the sum from n, and it is your new n. If the new n is in the list below, return the associated fruit. Alright. Otherwise, return back to task 1. So we're looping and such. This is a little more, this has a lot more steps than previous ones I've done. I can see why it's harder than other ones of this level, is because it's got a lot more steps going to it instead of just one or two things going on. Return back to task 1. I see. So example, if n equals 325, you're going to sum those numbers. So sum is 10. Okay. Okay, and then you do the sum minus the new n. The sum minus the new n, and you see if it's in the list, and it only goes up to 100. The list only goes up to 100. So, if it's over 100, then it's not in the list. Yeah. Then return back to task 1. Oh, I see. Okay, because this is the new n. So then the new n. So, you know what we're talking about here? We're talking about recursion. That's what we're talking about. Recursion is a function that calls itself until it doesn't. Until a base case is met, basically. So basically, I want to create a function, until you find the first n in the list below. There's no preloaded code to help you. This is not about coding skills. Think before you code. That's an interesting little thing to tack on there. Okay, anything under here? Nope. All right. So recursion is the first thing that came to mind here, because basically I'm thinking of a function, writing a function that basically does this. And then it keeps doing that. It keeps calling itself. A function that calls itself. I get really confused with recursion just because it's cyclical. I mean, it's just hard to wrap my mind around. The concept is simple enough to understand, but when I actually try to put it down there, it's a little confusing. But this is my chance to try. Okay. So I'm going to write a function that does these steps here. And then the base case is going to be basically if n, the new n, is 1 through 100, between 1 and 100. And you know what? This is complicated enough that I'm not even going to worry about returning the right correct fruit. I'm not even going to worry about that. It's just like an extra little fun thing. If I can just return the right number, if I can just return the number once it gets between 1 and 100, I'll call that a success. And then the added on thing of returning the correct fruit would be just a bonus. Yes. Alright, so let's give it a try. Train. Subtract some fruit named like apple. If I was going to return the fruit, I would basically make an array of all these items, either that or an object, and then I'd have to just return the fruit name that's associated with the number, and yeah, but that, like I said, it's like a little problem in itself. So I'll see if I can manage this recursion thing. Is the primary challenge in this, I would say. Okay. So the first thing I'm going to do is sum all the digits of n. So I'm going to take n, which is given here. So yeah, and if I don't see, this is the thing, is if I don't return a word, I'm going to fail all the tests. But I'm going to just do what I can do. If basic test function, subtract sum 10. Okay. So if I do n split, well, I guess I could say n to string split. You can add strings in JavaScript, though. It's just a thing. So I can do n to string split, and then I add them all up. So n to string. Can I just quick make sure I've got to string correct? I'm pretty sure that's how it is. It's pretty simple. I really like just, if I'm not 100% sure, yeah, see, there we go. If I'm not 100% sure, it's worth looking up, just because every time I look something up, I confirm it, I learn a little more maybe because I see a little extra thing that's listed with it. I like looking things up. So n to string, so then that's going to be whatever, so in this case it's going to be 10 as a string, and then I can say split, and then I'm going to, so that's going to be an array of 2 numbers as strings. Okay, and then to get those, it's going to be let's just make this a variable, which is what do I call the variable? Let integers or operands, there we go. No, numbers, I'll say let numbers, there we go, because it's multiple numbers. Let numbers, so that's going to be an array, and then for that array I'm going to basically reduce, that's what I'm going to do, reduce to return a single number, yes, so numbers dot reduce, whoops, and reduce takes it takes A and B, or the accumulated value and the current value, accumulated and current value, and runs it through this, which is, I'm going to say A plus B. Excuse me. All right, so that reduces, and that's going to be sum. So the sum is going to be numbers reduce this, okay? I think that should still work, even though they're strings. JavaScript is funny that way. It's not a very strict language. So that'll give me a sum. And then I'm going to see, now I'm going to have a little conditional statement thing, which is if it's between 1 and 100. Now if I did want to return these, I just hate that it's such a long list. But I could do it. I could make an array. I could make an object. I just hate that it's such a long list. And that sounds very tedious. Less than 10,000. But once again, this is not an overwhelming number, because guess what? Computers do things really quickly. Alright, so if I am going to do this, watch this. Watch this. This is really aggravating, but I'm going to do it. So here's what I'm going to do. Switch statement. I could either do a switch statement and have each of these numbers be a case, and in the case of these numbers you return the name of the fruit, and then the default is to basically go back and do this again. I know I was talking about recursion, and I haven't even gotten to that yet. I'm just thinking about how to return the fruit. You know what that means? Is that I'm getting ahead of myself. That's what that means. So the first thing, like I said before, is to figure out how to return the correct number until I get to numbers 1 through 100. That's the first step. Then I'll move on to the whole fruit thing. I have to get ahead of myself. And this is me talking to myself, which at an interview is not the best. You're supposed to have, at least here, like a conversation, and I'm not really acting like I'm sharing my thoughts with a real person in the room. I'm just kind of talking to myself. I'm doing the rubber duck thing, which, the interviewers would not necessarily appreciate. So I'm going to say that I'm getting ahead of myself if first I'm going to return the correct number, and then I will move on to the next step, which is returning the correct fruit name. And so far so good. I've got the sum, so that's good. Now all I have to do is check to see if the sum is a number between 1 and 100, and if it's not, I have to keep going, looping through this. So I have to remember how to set the base case in recursion. How do I set the base case in recursion? And the best thing to do is look it up. Recursion example JavaScript. The recursion. I'm clicking on it and it's not doing anything. Oh, here we go. Okay, so here's a simple example. Factorial, oh yeah, factorial gets used quite a bit as an example. Factorial x. If x is less than 0, return, yep. If x is equal to 0, return 1. Return x times factorial x minus 1. Now this is where I get confused. I'm like, wait, it's calling itself. Ah, you're not allowed to do that. That's weird. X times factorial x minus 1. Right, because it's multiplying. That's different than sum. Okay. Oh, this just hurts my brain just looking at it. But this is basically how you set the base case. See, that's x minus 1. So you just do a conditional, and if the condition is not met, it moves on. And then, I mean, it's basically looping through. So let's see if I can do that. Yeah, it's breaking it down. Termination. If x is less than 0, return. Ah, I see. Base. If x is equal to 0, return 1. X times factorial. You know what? And then it walks us through. Factorial 2, 2 factorial 1, 1 factorial 0. If x is equal to 0, return 1. Everything, our function has finally returned. Oh yeah, it didn't. Everything will unwind. A group of nested function calls. Most internested function will return first. Okay, so the base case is if oh, because I want to say if the sum, oh, maybe this won't work, because if the sum no, because I'm talking about a helper function here. That's what I'm saying. I'm not talking about recursion. No, I'm not talking about recursion. I'm talking about just looping through using a helper function. What time is it? How long am I taking? No, I bet you there's a simpler thing. I bet you I don't need to use recursion. Most of the time when you think you need to use recursion, you can usually achieve something with just a simple loop. So I'm going to take that approach since recursion is very confusing to me, apparently. So I've got the sum, and all I have to do, let me just forget about the recursion thing. I probably just overcomplicated things for no reason. I've got the sum. Basically, if if sum is greater than or equal to 1, right? Because it starts with 1. Or, whoops. Oh, no, I'm not going to say or, I'm going to say and. Because it also needs to be and sum is less than or equal to 100, right? Yep. 100 Does it say anything like it'll never be less than 0? Oh yeah. Oh, n is always going to be greater than or equal to 10 and less than or equal to 1,000, which means it's never going to be less than 1, because 10, the sum of 10 is 1. So it's never going to be less than 1. So it's never going to be 0. So that's nice to know. So, you know what, basically a switch statement would do it. Because I have sum as basically, if sum is equal to 1, do this. If it's equal to 2, do this. 3, do this, all the way to 100. And then the default is to go back to this this is the new n. Yep, it is recursion. That's why I thought about recursion, is because this is the new n that I'm returning. Yeah, because else, so basically I'm saying, basically I'm going to go through this sum, and the sum is going to be the new n. So it will end up being subtract sum n but it'll be subtract sum because that's the new n. And I mean, you know, it's n equals sum, so it'll be the new n. You know, so reassigning n here and subtract sum n. Yep. Yeah, so that is recursion then. It definitely is. N equals sum, subtract sum n. And then it'll go again and say basically if yeah, so I would have this condition here, and that would be the base case. That would be the base case. And if that condition is not met, it would go on here and call it again. I think that is what we're talking about. Yep, I'm pretty sure. Yep, we are doing recursion. That's crazy. This is supposed to be 8Q. How can you do recursion on an 8Q? That's silly. That's okay. Actually, I know someone who, this is a side thing, who at an interview was intentionally asked a very difficult algorithm, and he was not expected to know how to do it, or to, he found this out later, he was not expected to be able to solve it, but they wanted to see how he acted under pressure, basically. And I mean, he did not solve the algorithm, but he did get the job. So don't complain about being asked a question that's too hard for you, because there might be hidden purposes, I suppose. But back to recursion. I think I'm actually working this out. This is amazing, because I've never actually made myself understand recursion. I've always just kind of looked at it, kind of read about it, and be like, on to the next thing. But this time, I'm kind of sticking with it, so it's good. Yeah, so, but now I just lost my train of thought, so that's too bad too. So this is what's going to happen, and this is going to be basically my switch. This is where my switch statement is going to be. Switch statement. There might be a better way to do this, like creating an object or array or something, but because I would hate to do this 100 times, but that's the way they have it set up. So switch statement to determine root, and then what is going to happen in that switch statement is if the condition's met, you're going to return, I think I need a variable to return here, return fruit, and I'm going to initiate that, let fruit, and then fruit equals fruit, I mean whatever the yeah, that's what I'll do. Let fruit, and then fruit equals fruit. Whatever, that's the variable, and that's the fruit string. For example, kiwi. Let me just write the first one. I'll just write the first one, just to show what I'm doing here. Case 1. This is not going to be a string, because this is going to return a number, I believe. I hope it returns a number. What if it just concatenates the two strings, and 1 and 2 end up as 12? I might have to make them into integers after all. Yeah, so, yes. But that will just be a map, numbers.map. Wait, first I'll do, I'll just do it right here. Map dot reduce map, number, number to int. I think that's how you do it. I'll look that up too. To int JavaScript. Oh, parse int? Oh, that's what I want, parse int. It's to string and parse int. Right? This is really weird. Parse int, and then this is really weird. Parses a string argument and returns an integer. Oh. Wait, what? This example is really weird looking. It's all overlapped. What is going on here? That's strange. Let me look at this one. Okay, parse int 10. Oh, it's not a, you just do it. You don't, okay, well, that's fine. We'll do it that way then. It is not that, it's parse int number. Okay, I didn't realize that. I thought it was like to string. That's why I look things up, so I don't get things wrong. Number parse int number. Okay, so that should be a new array of numbers instead of strings, and then I can reduce. I just realized that could just put the two strings together, which is not what I want. Okay, and then let fruit, initiated fruit, and then here's the condition. If it's between 1 and 100 basically, then I'm going to say switch, and this is going to be sum. Yep, sum, so it's taking the sum, and in case 1, fruit equals kiwi. Case 2, oh my goodness, yeah, fruit equals, see why I didn't want to do this? I'm not going to do this 100 times. That's terrible. And then there's always a default value, default, which is just return, because I don't want to return anything. Just return. Oh, wait a minute. Switch I see, because the switch is within an if statement, so it's only going to get in here. It's only going to get in here if it's this. So anyway, default. Interesting. Okay, and then n equals sum. And subtract sum n. Return fruit. This is really strange. Now in here though, in this example of recursion, they had return x times factorial. I have to look at some other examples of recursion to see if this is what is going on. I mean, what would happen if I just return this? I mean, obviously I only have two cases covered here. Oh, well, syntax error. Am I not doing my switch statement right? What's going on here? Am I not doing my switch statement right? I use switch statements all the time in Redux. Oh, haha, there we go. Yeah, that's right. Right, because it's a function, so I'm going to have it in there and do a colon after that instead. Oh, I do have a colon after that. I just didn't put it in curly braces like you usually do with a function. That would be good. Oh, yeah, that would be good if I did that. Good thing to do. All right, now what? Oh, looking things up. Yeah, I mean, so obviously, I mean, wait a minute, passed 0, failed 1. Oh, so there's only one test? There's only one test. Fascinating. That's really weird. Seriously? Oh yeah, oh I see, because yeah, there's just one test listed here. I see, but when I actually attempt it, there's going to be a lot more tests. I get it. There's just one sample test to pass. Ha. You know what I'm going to do then? Since I know that's the test I have to pass, I'm going to put in apple. Case 9. Apple. Cheating! I just want to see if I can pass it with one thing. Nope, I can't. Well, here's another one I'm going to give up on. But, you know, I learned a lot here. Well, I reviewed I reviewed to string, which I haven't used for a while. Parse int I reviewed. I reviewed like switch statements, like doing the curly braces like a function, since that's what it is. Obviously, I even started understanding recursion a little bit better. And now I really like going to the solutions after this. Actually, I go to the solutions after every one I do, because even if I got it right, there's a lot of different solutions, and I learn more ways of doing things, basically. So why not just go through that right now, just to do it. So I'm basically giving up on this one. Unlock solutions. Yes, show me the solutions. I forfeit. Poor me. Okay. What in the world? Wait, is this seriously someone's solution? Someone seriously just returned apple? I'm gonna have to go back and try that. Now here's what I'm talking about, like make it into an object, you know? Make it into an object with, you know, with key value pairs, and go through each key, and it just seems like a lot of busy work for a single algorithm. So that's what turned me off about it. But you know, you gotta do what you gotta do. And then here's its actual thing here. Number n minus street. See, look at this. This guy did the same thing. He just cheated. He just returned apple. Oh my goodness. Oh my goodness. Oh, now this is interesting. Oh, because they repeat. I did not even notice that. I didn't even notice that they repeated. I thought they were all different fruit. Of course, there's not like 100 different kinds of fruits. I didn't even notice that. Oh, now this is really crazy. What is this person doing? What is this person doing? Wait, plus not array plus array. Now this person did the same thing, which is, oh, now he did an array, just like, I was saying I could do an array as well. Yeah, and they repeat. I didn't even notice that they repeat. Didn't look close enough. Yep. And then he did a while loop. Okay. Okay, but you know what? These crazy people who just return apple, can you seriously just do that? I'm going to try that. Can you just return apple? That is the test. Look at this. And it even said back here, what did it say? It even had a warning. This is not about coding skills. Think before you code. It's just a trick question. It's totally a trick question. Watch this. Oh my goodness, they even gave us a hint. Look at this. Fruit name like apple. Are you kidding me? I'm going to try it. I can't believe it was a trick question. Return apple. I can't believe it. Those stinkers. They got me.